People often wonder how Sir Isaac Newton's laws could possibly be right when they see objects in motion and then they see objects stop, but they don't see a force act upon it. However, what they do not realize is that Newton's laws of motion are mentioning all types of forces. Newton gives us 3 easy laws to help us understand motion. His first law is an object at rest will remain at rest unless acted upon. His second law of motion is an object at motion will remain at motion unless acted upon by another force. And his third law is for every action there is an equal and opposite reaction. So let's take a look at these laws more closely. Newton's laws of motion. His first one, object at rest will remain at rest unless acted upon. So what this means is that if an object is at one place, it will not move in any way unless it is acted upon by another force. This happens in our daily lives, and sometimes we don't even realize. An example of this. Here's a book. This book is not moving. This book is at rest. However, I could be an external force and move the book around, and now this book is no longer at rest. But if I let my hand go, the book is at rest again. Another example of this, we could use this ball. That ball is also at rest. However, I could move it with my hand, and now this ball is no longer at rest anymore. Newton's second law of motion is that an object in motion will remain in motion unless acted upon by another force. Newton also gives us an F equals ma formula. Let's write that down. F equals ma. Force equals mass times acceleration. To me, this is one of Newton's most powerful laws because it shows how velocity can change when forces are applied. So Newton and Aristotle kind of differed in this one. For Aristotle, used an F equals mv formula for mass and velocity is equal to force. But Newton uses an F equals ma formula for mass and acceleration equals a force. Newton said that an object with a certain velocity will maintain that velocity unless a force acts on it to cause a change in velocity or a change in acceleration. So an example of this, we're going to use this ball again. This ball will move and it will stop by an external force. But if that force wasn't there, the ball would have kept moving. That ball was rolling, and then the wall was the external force, and it stopped it. It also bounced back a little bit as to show for a change in acceleration, or velocity. Newton's third law of motion is for every action there is an equal and opposite reaction. So this one's kind of fun to show because I'm going to use this balloon and I'm going to blow it up, but I won't tie it so it won't fly away. So Newton's law, what he means by this is that whatever is done to an object, the object does the same thing back to the object. Okay, so there's air in this balloon, and you're going to see when I let it go that the air is going to shoot out. You'll see these effect by when it hits my hand. And the balloon's going to fly another way because it has for the air is the action and the balloon flying the other way is the reaction. Ready? Did you see that? Let's show it one more time. So, as you just saw, the air was the action, blew up my hair, and the balloon flew the other way as the reaction. Another thing to also consider is that friction is a force, and there's friction everywhere. There's friction on the floor, and people just don't really consider it. So sometimes people who asked the question earlier of they just don't really see it, they just don't really know sometimes. Friction is a force, and it could slow down or move an object. Now hopefully you know all about Newton's laws of motion as you teach it, for it's very simple using balloon, a book, and a ball. Another thing to consider is that these laws were tested, so you know that they're very right. For Newton had a theory, tested it, and it became an observation. And after the observation was tested by multiple people, it became a law. So I really hope you learned a lot about Newton's laws and about motion. Thank you for listening.